For the first time in history, doctors have successfully used custom-made gene therapy to treat a baby born with a rare genetic disorder. Last summer, KJ Muldoon was born with a rare metabolic disease that affects just 1 in 1.3 million babies. It's fatal for nearly half of the infants diagnosed, according to a study in Science Direct. Experts had previously thought the only long-term treatment was a liver transplant. Using a technology called CRISPR, teams at the Children's Hospital of Philadelphia and Penn Medicine created a personalized gene editing therapy to find the one mutated gene out of the 20,000 in KJ's body and fix it. CBS News chief medical correspondent Dr. John LaPook spoke with KJ's parents who hope to bring him home in the next few weeks.
What's it like for you now to hold your son in your arms?
Now when I get to hold him and he's laughing and jumping around, that's a very heartwarming, because I didn't know if that was going to happen at one point.
Dr. Peter Marks wrote an editorial accompanying the research paper on this case. He's a physician scientist and the former director at the Food and Drug Administration Center for Biologics and Evaluation and Research. He resigned as the agency's top vaccine regulator in March. Doctor, thank you so much for being here. We appreciate your time. What can you tell us about what KJ's prognosis was before this and what it is now?
So before the administration of this gene therapy, the prognosis was pretty grave. About half of the children who make it to liver transplant, but even those sometimes are very severely affected by the metabolic abnormalities and have lasting lifelong abnormalities, even if they do make it to a liver transplant. So this is really a potentially transformational treatment for this child.
How did we get here? I mean, I know it took decades of research and advancement.
Yeah, this is an amazing tour de force of science, where it's linked up the ability to rapidly get a genetic diagnosis that's accurate, to take that diagnosis, create a medicine, and then put together the protocol to administer that medicine in a way that allowed it to potentially bring benefit here. And so far, although it's early on, it looks like it's actually doing what it's supposed to do.
Can this potentially be adopted to address other conditions?
Yeah, that's what's so exciting about this technology, because this is a little bit like a letter in an envelope, where for other conditions now, not for every other one, but for some, all it's going to be required here is changing the address. Wow. As opposed to rewriting the letter and sticking it in the envelope. So this could be a significant game changer, particularly at first for these children with very rare diseases, but ultimately for a larger population of individuals with some more common diseases as well.
Are there any limitations in this kind of custom-made gene therapy? And also on that note, what kind of monitoring does baby KJ still face?
Yeah, so some of the limitations that have to be overcome right now is that we can't send this stuff to every address. Only certain places can be addressed. The current addressing does not go to some places like the brain as easily. There are ways to get it there, but it's more complex at this point. Those will probably be overcome in the next few years. And obviously, this child will be monitored closely because we'd like to make sure that this obviously is going to persist over time, and these benefits will last over time without any adverse effects. I mean, it's obviously early on, but so far incredibly encouraging to see.
Well, Dr. Peter Marks, we appreciate your time. I particularly appreciate the letter analogy. It helps my non-scientific brain understand and get a grasp. Thank you so much.
My pleasure. Thank you.